Yeah, so here this is the junction box. I forgot to present this area where you can see the arrangement of conductors. The arrangement of conductors for the purpose of carrying current. So you can see here, as the Ohm's law states, that the current flowing in a circuit is directly proportional to the voltage and inversely proportional to the resistance at a constant temperature, which states, according to by expression, V all over I arrow. So meaning that everything that has to function here, it involves the load, it involves the voltage, and it involves the resistance. So when you want to define a cable in engineering, you can say a cable is a length of conductor which conducts a length of wire. As the Americans say, a length of wire, but we in the British, we say a length of conductor, which is installed in an electrical circuit for the purpose of carrying electrical current, or you call it the locomotive electrical energy. So you see, a job well done as it was done and terminated by me. So you can have here the galvanized cup, S4 in America. We call this one S4 in the engineering terms. So you can see how the cables have nicely gone into it. They have their various gauges. You have gauge 12 in the American standard, and then you have the gauge 14 in the American standard. In the British, for those of us who have done all round, it is a 1.5 millimeter cable that is carrying the illumination, and the 2.5 wire, 4 by 3 by 2.5 wire conductor that is going to the power unit, which involve L1 and N, and then with the earth, L1 and N with the with the earth wire that people call it in America the ground wire. The L wire is there to sustain the abnormalities that come into the circuit. For anything like a thunder, eclipse, the right equipment that is controlling it, the sensitive places like the circuit breakers, the OCDPs, the HFIC, or you call it the high factor circuit interrupter. So they are in charge of issues that come into the installation. Normally they break them off so that any situation of combustion on the electrical flame will not affect the installation. So when these cases happen, an electrician is called on to check to see actually what has caused the OCDP, overload protection unit, to trip off, or the HFIC, or you call it high factor circuit interrupter. So these are the things which are guiding the installation to function well. Or if you never mind, you can say the fuse. Fuses have been now transferred to the high equipment which are so sensitive, like the circuit breakers and the HFCI, which is a high factor circuit interrupter. So they are more faster than the fuse. Anyway, which a fuse is, as you can say, a fuse is a weak point in an electrical installation, which helps to break off the circuit in case of an excessive flow of current. So they are just a guide to the electrical installation, so that it should run smoothly, so that if there's any situation, you will not find some cables burning off. All those people are there, like the pillars of an installation, or like the pillars of the installation that are so sensitive to keep the function of the installation to go smoothly. Yeah, so like I said, I am the manager of Ohms Electrical Engineering company now existing in Los Angeles. I'm based in Los Angeles. Send all your questions to me and they will be answered. Yeah, even in the HSOS, which means that the house service overhead system, I am very competent to give you classes on there, starting from the high voltage, medium voltage, low voltage, extra low voltage. I am very competent to give classes to anybody who calls this number, 323-784-5176. I'll be able to assist you guys. Thank you very much.